Hey guys, welcome to AKV and this is Vishnu. So in this illustration, a manager is trying to decide which of the three mutually exclusive projects to undertake. Each of the project could lead to varying net profit, which are considered as outcome 1, 2 and 3. The manager has constructed the following payoff table or matrix: a conditional profit on table. The net profit outcome turn out to be, they have given a table contains outcome and then projects A, B, C and C, and then we have three possibilities, which is one weak, second one most likely, and third one best. The probabilities will be zero point 0.2, 0.5 and zero point 0.3. The outcome of A with three alternatives would be 50,000, 85,000 and 1,30,000. For project B it would be 70,000, 75,000 and 1,40,000, and for project C will be 90,000, 1 lakh and 1,10,000. And they are required us to select which project should be undertaken, and second one, which project is profitable if the minimum regret rule is applicable. So we have two questions, two requirements. So going ahead with the solution, if the project with highest EV of profit should be selected, so over here it should be C. So for that computation, I have prepared a table containing 5 columns. Number 1, outcome 1, 2, 3, that is weekly, most likely, and strong demand or higher demand. And then we have probability 0.2, 0.6 and 0.2. So here the probability has, there is a mistaken probability, it would be 0.2, 0.5 and 0.3. Then we have the project EV. So the project EV of project A would be nothing but when we multiply probability with the outcome. So 0.5, 0.3, 0.2, 0.5 and 0.3 are the probability. Therefore for the project A would be 50,000 multiplied by 0.2 and 85,000 multiplied by 0.5 and 1,30,000 multiplied by 0.3. The same way we have project B and project C, and when we take the total, it would be, for project A it would be 95,500 and 93,500 for project B, and 1,01,000 for project C. So a table, so from here we can easily select that the project C is much more higher EV than when compares to other projects, which is project A and project B. So now we can go ahead with the minimum regret method. So a table of regret can be complied as following, showing the amount of profit that might be foregone from each project depending on whether the outcome in this 1, 2 or 3. So over here we have taken the outcomes, 1, 2, 3 are the outcomes, and we have taken the projects EV. Therefore we should compare all three alternatives, that which means three projects, and among three projects we should take the minimum, maximum, and we should deduct it from the entire projects, which is maximum for the weak outcome category would be 90,000. Therefore 90,000 minus 50,000, 90,000 minus 70,000 and 90,000 minus 90,000. Okay, so 90,000 minus 50,000 is 40,000, 90,000 minus 70,000 which is 20,000, 90,000 minus 90,000 which is nil. Going ahead with most likely demand, the most highest amount would be 1 lakh. Therefore 1 lakh minus 80,000, 1 lakh minus 85,000, 1 lakh minus 75,000 which is 25,000, and 1 lakh minus 1 lakh which is 0. And going with best demand, it would be the most higher among three alternatives would be 1,40,000. Therefore, 1,40,000 minus 1,30,000, which is 10,000, and 1,40,000 minus 1,40,000, which is 0, and 1,40,000 minus 1,10,000 will give you 30,000. So the maximum regret rule is 40,000 with project A, 25,000 with project B, and 30,000 with project C. The lowest of three minimum regret rule is 25,000 with B, and so the project B would be selected as minimum regret rule is used. Note the minimum regret rule aims to minimize the regret from making the wrong decision. The regret is an opportunity lost through making wrong decision. So here the minimum regret rule, when it compare from this 40,000 for project A and 25,000 from project B and 30,000 from project C, we can find that 25,000 is much more lesser than the other through two alternatives. So for minimum regret rule, it is better to choose project B. So guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe.